has been used as a means of joining metals for thousands of years. Perhaps the earliest application was in the manufacture of jewelry, using the precious metals gold and silver. The Romans manufactured lead pipe by rolling lead flat, forming it into a cylinder, and soldering it with a metal alloy which we call pewter today. Soldering is still used in the manufacture of jewelry and in plumbing installation, but it has also become a fundamental part of a new and rapidly expanding field, the electronics industry. The heart of the electronics industry is the interconnection of electronic components into a unit that has both mechanical security and solid electrical interconnection or continuity. Soldering fulfills these requirements. Let's look into the nature of the solder bond to see why. Solder is a mixture of tin and lead, called an alloy. A peculiar characteristic of this alloy is that it melts at a temperature much lower than either of its component metals. The ratio of tin to lead determines the specific melting temperature of the solder mixture. The most commonly used solder in the electronics industry is the 60-40 tin-lead type. Shown here are some of the typical solder mixtures and their melting points. Solder comes in a variety of forms. The most common in electronic hand soldering is wire solder, which ranges in diameter from a few hundredths of an inch to 1/4 inch. Bar and block solders are used in automatic soldering techniques. Bar solder is melted into a solder pot for wave soldering of printed circuits or for dip soldering. Block solder is drawn into solder ribbons to be used in other automatic industrial applications. When hard-to-reach areas must be accurately soldered, or many connections are to be soldered to one component, solder forms are used. These apply a carefully measured amount of flux and solder to an area of specific shape. Solder may also be applied as a paste or powder when the piece to be soldered is difficult or impossible to reach after previous assembly. When a good solder bond is formed, the surfaces joined by the solder are dissolved slightly by the molten solder. When the joint is cooled, the metal and solder are continuous with one another, since the base metal and solder have mixed slightly. By cutting a cross-section through a solder copper bond, it is easy to see that the solvent action of the molten solder has affected the surface of the copper. This action of the solder is called wetting. But in order for wetting to occur, the solder must come in contact with the pure base metal to be soldered. Most of the time, an unprepared metal surface is covered with the product of a chemical reaction between the metal and oxygen in the air. This product is called a metal oxide and will totally prevent the formation of a solder bond. To overcome the oxide coating on metal surfaces, a substance called flux is used. In soldering for electronics, fluxes made from the sap of pine trees are used. A flux, which has extra ingredients to better dissolve the oxide coating, is called activated flux. The flux has three main functions in soldering. First, it provides a barrier between the metal surface and surrounding air in order to protect the surface. Second, it helps the solder to flow more easily by promoting the wetting action of the solder. And third, it partially dissolves the thin oxide coating normally found on the base metal. A clean solderable metal surface is known as an active surface, since it is free to react with the solder to form a solid solder bond. Now that we understand something of the process of soldering, let's look at the materials, tools, and processes involved, and their names. Perhaps the most fundamental item of hardware used in soldering is the soldering iron. This device is used to apply a precisely controlled amount of heat to the parts to be joined. For industrial applications, the large soldering iron is used. This may be equipped with a wide variety of tip shapes and sizes to meet the differing demands throughout a shop. Most heavy-duty soldering irons generate a relatively high temperature and draw in the neighborhood of 100 watts. In the manufacture of delicate electronic instruments, a much smaller device is used, frequently called a soldering pencil. These also have changeable tips, but draw a much lower level of electricity, from 10 to 35 watts. To control the heat of simple soldering irons or pencils for different jobs, the technician uses a variable resistor, or variac. This device is adjustable so that current passing through may be limited, lowering the temperature of the soldering device. When accurate heat control as well as high temperatures are required, a soldering gun is used. These frequently draw as much current as a heavy-duty industrial iron, around 100 watts, but have a trigger switch so the operator can shut off the gun when the appropriate heat is reached. When many tightly spaced connections are to be bonded, a different type of soldering device is used. The resistance soldering unit passes electricity through the area to be soldered, making a controlled short circuit. The piece to be soldered heats up from the shorting until soldering temperature is reached. We observed the nature of the solder bond on flat copper plate earlier. All soldering occurs in this way, but naturally electronic components are not so simple and cooperative. In electronics, we find a wide variety of components, such as resistors, capacitors, transistors, and so forth. These are interconnected with conductors, such as copper wire, and are frequently mounted on specially designed posts called terminals. The wires leading out of components are known as leads. These leads... Until recently, the electronics industry has been in its infancy. The simple circuits and bulky components that developed early could easily be assembled through the use of wire conductors. As electronic components grew more exotic and compact, wire was still used. The numerous conductors were identified by color-coding schemes. Today's components, however, are so excessively small and circuits are so complex in their intercommunication that wire has been replaced to a great extent by a new type of conductor, that found on the printed circuit. The printed circuit, or PC board, has conductive strips of copper which interconnect lead mounting pads called lands. The lands and conductors are part of a continuous piece of copper which is laminated onto a sturdy insulative backing. The printed circuit is made from a solid sheet of copper bonded to the backing material. Soldering on a printed circuit is usually done with a 30-watt soldering pencil rather than a larger 100-watt iron or gun-type unit. Clean the component leads if necessary, and tin them if they were not tinned at the time of manufacture. Clean the lands of the PC board gently with a typewriter eraser. Clean copper has a dull, pinkish appearance. Measure the lead spacing necessary to fit a component correctly into the PC board. Bend the leads 90 degrees where they need to pass through the land mounting holes, and fit the part to the board so the component is situated on the non-clad component side of the board. You must now fix the component in position and clip the excess lead prior to soldering. Several methods have been developed to accomplish this. Component accessibility and mechanical security dictate which method should be used. Clinching is considered to be the soundest method for mounting soldered components to a PC board. To clinch a component into position, press it firmly against the surface. If it is a heat-sensitive component, a spacer may be used to elevate it. The leads of the component must be clipped long enough to be bent parallel to the conductor side of the PC laminations. Mount a cleaned PC board in your vise or clamp it to your desk. Then fix the component in its place on the printed circuit. It may be helpful to apply a droplet of solder to the end of the clean tinned tip of the soldering iron. This transmits heat to the work more quickly by providing greater surface area for heat transfer. Heat the lead and land simultaneously. Less heat is required to solder printed circuit connections, so watch carefully to determine when the joint is hot enough to solder. Start feeding solder into the joint from a position opposite that of the iron tip. Feed solder into the joint. Take care to cover the land totally, yet leave the clear contour of the lead visible through its coating of solder. After withdrawing the solder, hold the iron in place for a moment, then remove it. Often you will be required to mount integrated circuit, IC components. These consist of a miniature printed circuit pattern and the necessary lead pins for connecting this circuit into larger ones. IC chips are prone to be heat sensitive and may be ruined by the soldering process. To avoid this problem, sockets have been developed which may be soldered into the PC board. The integrated circuit chip is then plugged into the mounted socket pattern